Hello everyone, welcome to the next lecture on the linear transformation. Today I will explain you 32 examples in this lecture with this one of the most easiest way. Myself Dr. Harish Garg. You can follow my YouTube channel so that you can get the more information about my channel. What is the linear transformation? If you have the two vector space V and W, any of the mapping from the V to W is said to be the linear transformation if it satisfies these three properties. Or instead of the three property, I can combine the second and the third property in a one single map. Now the question arises is how you can check whether it's a linear transformation or not. In order to prove that whether the transformation is linear or not, you have to satisfy these two properties. If you prove that these two properties are satisfied, then it is a linear transformation. And if any one of this property is not satisfied, you have to provide the one counter example, then you can say it is not a linear transformation. How you can prove or disprove the linear transformation, that you will learn in this lecture. I will explain you this with the help of the 32 examples in this video. I hope you can subscribe and like my YouTube channel and moreover this video so that you can get the more information. Firstly, I will give you the tips. How you can check it firstly whether it's a linear or not. Look at the term. What is the term involved? It's your target to check this property, but before that you can see it's a mod of x, it's a y minus z. Clearly say y and z both have a linear. Fine. What is that? Does the mod x is a linear? No. Y mod x is always the non-linear. So hence, is it a linear transformation? No, it is not a linear transformation. So once it is not a linear transformation, you have to provide one counter example. But remember, firstly you have to satisfy this property in each case. Take any element from the domain 0, 0, 0. This is a part of the domain. Fine. Check whether t of 0 is 0 or not. If you substitute x is a 0, y and z are 0, 0. So the first property is satisfied. Fine. Now, if this property is satisfied, then always look about this property firstly. You may choose about this property, but I suggested you always choose this property. Now, take any element from the domain, say 1, 2, or 3, fine. Or you may choose 1, minus 1, 0, or you may choose root 2, 4, 1 over 3, any of the number, that's on your choice. So let's say I can choose u is 1, minus 1, 0. Can you calculate the value of the t of u? This is my x, this is my y, this is my z. If I substitute here, it is my 1, y minus z is minus. Fine. Now, whenever you will see any of the quantity written in the mod value, then choose always alpha as a negative number. Fine. I can choose alpha is my minus 2, which is a part of the real number. Always taken as a negative when mod is given. If mod is not given, then it's on your choice whether you want to take alpha as a positive or negative. Then what is the value of the alpha u? This is my alpha, this is my u. If we multiply them, it's a 2 minus 2, 0. Find the value of the t of alpha u. Now this is my x, this is y, this is z. If I substitute this, 2 minus 2, 0, 2 minus 0 is this number. Does it equal to alpha times t of u? Alpha is my this, t of u is my this. If you multiply them, it will be minus 2 plus 2, but we need a both as a positive. It means they are not equal. Hence, they are not linear transformation. Look at the second example. Firstly, take the elements from the 0, which is from the domain. What is that t of 0? 2, 0, 0. It is not equal to 0 because the one non-zero element will be there. Hence, it is not a linear transform. Always start from the 0 firstly. Clearly say again, x square is always a non-linear. So that means this is my not a linear. So if it is not a linear, you have to provide one counter example. Firstly, quickly check whether t of 0 is 0. So 0 square, 0 square, 0 square satisfied. So I can choose any of the u. So you may choose 1, 2, 3. You may choose 1 over 4 minus 1, 0 as per your convenience. Fine. I can choose u as a 1, 0, 0. Then what is the value of that t of u? 1 square plus 0 plus this. Choose any of the alpha. I can choose alpha is my 3 because the mode is not given. You can choose any of the number. Then what is the value of the alpha into u? 3, 0 and 0. Alpha is my this, u is my this. So therefore, what is the value of the t of alpha u? This is my x, this is my y, this is my z. So 9 plus 0. So does it equal to alpha times t of u? Alpha is my 3, t of u is my 1. If you multiply them, it will be give a 3, but we need a 9. Hence, it is my not a linear transformation. We all know cos and sine are non-linear, so therefore it's a not transformation. I can take firstly 0. Fine. What is the value of the t of 0? Cos 0, 1, sine 0, 0, e raised to power 0, 1, which is not 0. Therefore, t is my not linear transformation. Fine. Otherwise, you can also choose this property as on u. So if I choose any of the u, that's a pi. Why I taken as a pi by 2? Because it's a cosine sine. What is the value of that t of u? Cos 90, 1. Cos 90, 0. Fine. Sine 0, 0. E raised to power 0, 1. Now choose any of the alpha. I can choose alpha is say my 3. Fine. Then what is the value of the alpha of u? Oh, I can choose alpha as a 2. That could be easy because pi will be cancelled out. So then it will be pi 0, 0. What is the value of the alpha into u? So cos of pi minus 1, sine of 0 is 0, e raised to power 0, 1. Does it equal to alpha times t of u? Alpha is my this, t of u is this. So it will be 0, 0, 2, but they are not equal. So therefore, t is my not linear transformation. Fine. So you can see, and if I substitute alpha is this, you will get the again number this one. Now check whether it's a linear or not. What is the degree of this? Degree is my 2. Clearly say this is my not linear. Check whether 0 satisfied. 0, 0, that's a 0. I can choose any of the u from the domain, that is a R2, 1, 1. What is the t of u? 1. Choose any alpha, say alpha is my 2. Fine. Then what is the value of the alpha into u? 2, 2. Fine. Or you can choose any of the alpha, that's on your choice. What is the t of alpha? Now this is my x, this is my y. 2 into 2, 4. Does it equal to t of u? Alpha is my 2, t of u is my 1. The product will be 2, but we need a 4. Hence, it is not a linear transformation. Does it a linear? It is not a linear because x square is not a linear. Does it 0 satisfied? Yes, 0 satisfied. I can choose any of the u. Choose any of the alpha. Say alpha is my 3. Fine. Then what is my alpha of u? 3, 6. What is the value of the t of alpha u? So it's a 9, 36. Does it equal to alpha times t of u? Alpha is 3. 3 into t of u, that's a 3, 12, but we need a 9, 36. That means again it is not a linear transformation. Look at this part. It's a x plus y and y. This is my linear. This is my linear. So that means yes, this is a linear transformation. So once it's a linear transformation, you can never take an as a counter example. Fine. So it means you have to prove these two properties. Take 0 element from the domain. What is the t of 0? X plus y. 0 plus 0, y. So that is a 0. The first property satisfied. Now second property. Take u from the domain x1, y1. V again from the domain x2, y2. From this, make sure student, you can never take an as a counter example that 1, 2, v as this. Once you prove that it's a linear transformation, you have to prove by a standard procedure. Then what is the value of the t of u? If I substitute the value of u, that is x1, y1. x1 plus y1 comma y1, t of v x2 plus y2, and take alpha and beta are my two real numbers. Then can you find this value of alpha u plus beta v? This is my u, this is my v. I can multiply this by alpha, so it's alpha x1 beta x2 and alpha y1 beta y2. Again you can see this is the part of the R2. Now compute this number. Fine. Once you apply the capital T, that means x plus y. This is my x, this is my y. So x plus y and this is comma y. So whenever you have to written here, the first bracket you have to write in terms of the two bracket always. In each example, this part consists of all those terms which involve the alpha, this terms which involves the beta. For example, alpha x1, any other term plus alpha y1, comma, in this case alpha y. Similarly, you can write here all those terms which involve the beta. Now if I take alpha as a common, it is x1 plus y1 comma y1. If you take beta as a common, it is x2 plus y2 comma y2. What is this term? Can you identify that? This is my t of u and the second term will be my t of v. So hence this value will be satisfied. Therefore this is my linear transformation. Does it a linear? You have the three terms x plus y, x minus y. So this is linear, yes. Is it a linear? Yes. This is linear, yes. So it means this is my linear transformation. You have to prove like this method. I hope you can like and comment on my video. You can see this video is useful for you. Put a like to support my videos. Now take u and v are the part of the R2. What is the value of the u of v? Substitute this number x1 plus y1, x1 minus y1, y1. What is the t of v? x2 plus y2, x2 minus y2 and y2. Choose alpha and beta are the two real numbers. Find alpha u plus beta v. This is u, this is v. I can find this number. Then find alpha u t times alpha u plus beta v. This component is my x, this component is my y. I can substitute this part as x plus y. This is the x plus y, x minus y, comma y. Again the same rule. Choose all those components which involve the alpha and choose all those components which involve the beta. So this is alpha x1, alpha y1, comma. Second part is alpha x1 minus alpha y1, comma. Third component is alpha y. Similarly for the beta components I can return. For the first part I can choose alpha as a common. Then it is x1 plus y1, x1 minus y1 and y1. From the second part I can choose beta as a common, x2 plus y2, x2 minus y2 and y2. Clearly say this quantity is called as a t of u, this quantity is called as a t of v, hence this result is linear transformation. Now look at this quantity. Now f is the any function. So that's a very simple. You can firstly check about the zero property. If f of x is 0, what is my t of f? That is a t of 0. That is a t of 0. So what is the f of 0? If I substitute x0, 0. What is the f of 1? F of 1 is again 0 plus 1. Clearly say this number is my not 0. What is the meaning of that? It is my not linear transformation. Fine. This is the first method. That's why I always suggest you use the property of the 0. Second way, you can choose any of the other f of x. So you can choose f of x is 1, or you can choose f of x is x square minus 1. You may choose x square plus x plus 1 as on your choice. So for the simplest case, I can choose f of x is 1. What is the value of the t of f? Substitute this. What is the f of 0? 1. What is the f of 1? 1 plus 1. That means t of f will be 1 comma 2. Choose any of the alpha from the real number. Fine. I can choose alpha is my 2. Then what is my alpha of alpha into fx? That is a 2 into 1 is 2. Fine. I can find the value of t of alpha. So again, this is my this from this. What is the f0? When you substitute 0, answer is still 2. When you substitute 1, answer is still 1. So that means it comes to be 2 comma 3. Does it equal to t times of this? Alpha is my 2. T of f is my 1 comma 2. It will be 2 comma 4, but we need a 2 comma 3. Hence, it is not a linear transform. Kindly put a like on my video. Okay. What is the M? M is the matrix. T of A is the determinant. Okay. If I say A, B, C, D is my determinant, how you can find that determinant? ED minus BC. Clearly say the degree is my 2. That means it is my not a linear. So once it is not a linear, you have to find the counter example. I can again use the property of the alpha. Fine. Okay, so you can choose any of the A. The simplest one is identity matrix. Then what is the T of A? Determinant is 1. Choose any of the alpha. I can choose alpha is my 2, which is a real number. Then what is my alpha into A? Alpha is my 2. Multiply with the matrix A, you will get this number. What is the T of alpha A? T of alpha is the determinant of this 4. Does it equal to T times of the matrix A? T of A is my 1. Alpha is my 2, which is not equal. Hence, it is my not linear transformation. Now you can see about this property. X square is a non-linear. Fine. So that means we have to provide the counter example. Counter example corresponding to this case. Okay. Or you can use the counter example for this one also. I always prefer, as I told you earlier, I always prefer for this one because it will take a less time. You can choose, firstly check whether the 0 satisfied. T of 0 is equal to 0 square is 0 satisfied. Fine. Now choose any u from the domain. So domain is a real number only. So I can choose u is my 3. Fine. Or you can choose u is my 1. You can choose u is minus 3 and so on. So I can choose u is 3. T of x is my 9. What is the alpha? You can choose alpha is my say 2, which is the part of the real number. Then what is my alpha of u? Alpha of u is my 6. What is the T of u? X square 36. Does it equal to alpha times T of u? No, it's 18, but we need a 36. Hence, it is not a linear transformation. Also, you can use the second property. You can choose the two values. Say one is the 2, second is the 1, for example. Then what is the T of u? 4. What is the T of v? 1. Then what is the u plus v? Instead of the alpha property, you can use this property also. Then T of this is my 9. So can you say T of u plus v is equal to this? Again, you can see they are not equal. It's a 9, but it's a 5. Again, you can say this is not a linear transform. That's on your choice, whether you want to use alpha property or this. But I always recommended this one. Okay, look at this. Firstly, you can check about the 0 property. So it will be 0 plus 1. 1 minus 2, 0, which is not 0. Therefore, it is not a linear transformation. You can also check about the alpha property if you want. You can choose any of the alpha, any of the u, say 1, 0, 0. Then what is my T of u? It is 1 minus 2, 0. You can choose any of the alpha, say alpha is my 2. Then what is my alpha of u? 2, 0, 0. What is the value of the T of alpha u? So this is x1, this is x2, this is x3. x1 plus 1, 3, 0 minus. So does it equal to alpha times T of u? Alpha is my 2, T of u this, clearly say they are not equal, hence it is not a linear. You can see the right hand side, you can see it's a linear. Fine. So once it's a linear, you have to prove these two properties. Take the 0 element from the domain. What is the P2? P2 is the polynomial of degree less than equal to 2, that means a 0 polynomial. If I substitute this value, what is the A0? Constant term, constant is 0. A1, coefficient of the x. A2, coefficient of the x square. The first property satisfied. Now you can choose the two elements u and v from the domain. Domain is my P2. So P2 is the polynomial of degree this. So I can choose this is A0, A1x, A2x square, and for this case is a B0, B1x, B2x square. What is the value of that T of u? The sum of the coefficients, and T of v is B0, B1, B2. I can substitute this is my u, this is my v, substitute this value, you will get the polynomial expression. Find the value of T of u plus beta of v. This complete is my A0, constant term. This complete is my coefficient of the x, and this complete is my coefficient of the x square. So I can add them. Fine. Again, the first bracket will the coefficient of the alpha. This is alpha. Fine. I can take these three components as a first part. I can take alpha as a common. Now what is this number? This number is my T of u. This number is T of v. Hence, this is my linear transformation. Kindly subscribe my YouTube channel. Now clearly say mode of x, which is a non-linear. Fine. So you have to provide the counter example. You can choose any of the u. So let's say u is my 1, 0, 0. What is the T of u? 1, 0, 0. Or as I told you, you can choose any of the u. If I choose u as a 2, 1 and minus 1, then T of u will be this. What is the alpha? Because it's the modulus value, I can choose alpha is my minus of 2. Fine. Then alpha of u will be minus 4, minus of 2, plus 2. You can choose alpha is my minus 1. You can choose alpha is my plus 3. That's on your choice. Fine. So I can choose alpha is minus 3. What is that T of alpha u? Mod of x1, 6. x2 minus x3, minus 6, 0. Does it equal to alpha times T of u? Alpha is my this, T of u this. Minus 6, 0, but it's a plus 6. They are not equal. Hence, it is not a linear transformation. Again, you can see it's x square. It's a non-linear. 0 satisfied because 0, 0 is 0. Okay. I can choose the two numbers. Fine. Or v I can take as say 1, minus 1. What is the T of u? You can choose as alpha property, but alpha property in this case is satisfied. So what is the T of u? 1 plus 4, 5. What is the T of v? 1 plus 1, 2. Then calculate the u plus v. U plus v will be 2, 1. What is the value of the T of u plus v? It is 4 plus 1, 5. Does it equal to T of u plus T of v? No. Hence, it is not a linear transformation. You have to provide the one counter example. This is a linear, this is a linear, this is a linear. Yes, it is a linear function. Fine. So firstly, check about the 0. 0 satisfied. Take u and v from the domain. So x cube, x1, y1, z1, x2, y2, z2. So can you write that T of u? T of u is x1 plus 3y1 minus 4 z1. Similarly, T of v. Can you find the value of alpha u plus beta v? This is my u, this is v. So it will be alpha x1, beta x2, comma alpha y1, beta y2. Similarly for the z component. Start with this alpha u plus beta v. This complete is my x, this complete is my y, this complete is my z. Again the same rule, the first bracket will consist of all those terms which involve the alpha and second which involves the beta. That is alpha x1, 3 alpha y1 minus 4 alpha z. Take alpha common, it will give you alpha common, that will be give you x1 plus 3 y1 minus 4 z1. Beta common, you will get x2 3 y2 minus 4 z2. What is the value of this? T of u. What is the value of this? T of v. Hence this is the linear transformation. Now clearly say this is a mode of x is a non-linear. That's a simple, you can choose any of the u. You can choose any alpha, let's say alpha is my minus of 2, fine. Or you can choose alpha is minus 1, that's totally on your choice. What is the alpha of u? X minus y, 1. Does it equal to t alpha of this? It's a minus 1, but we get a plus 1. Hence it is not a linear transformation. Does it a linear? Mod x is always the non-linear. Choose any u from the domain. What is the t of u? This alpha I can choose as I say minus of 2. You can choose as a minus 3. Your alpha u will be this number. What is the t of alpha? Mod of x, that is this. It is not equal to alpha times this because it will give you the minus of 2. Hence it is not a linear transformation. Does it a linear? No, because x square is not a linear. Does the 0 satisfied? 0 satisfied. So I can choose any of the u. Because the mode is not given, you can choose any of the alpha. What is the alpha of u? X square 4. No, it's a minus 1. Fine. U, x, y is my minus 1. So alpha u, x square, y will be minus 2. Does it equal to alpha times of u? No, because it's a 2 and minus 2, but we need a 4. Therefore it is not a linear transformation. Does it a linear? Again you can see x square degree 2. This is a degree 2, degree 2. It is not a linear transformation. Does the 0 satisfied? So 0 square plus 0, yes, 0 will be satisfied. So I can choose any of the u. Fine. So I can choose any of the alpha. Alpha is say my 2. Then what is the value of the alpha u? X square 4, xy 8, xy 8, y into z 8. That will be 12, 8, 8. Clearly say which is not equal to alpha times, because t of u is this, alpha is this will give you the 6, 4 and 4, but we get a 12, 8 and 8. Clearly say this is my linear. Fine. Also you can see t of 0 is my a times 0 is my 0. That's satisfied. So I can choose the two vectors, that is a x, that is x, u is x, fine, v is my y, fine. What is the alpha u plus beta v? That is alpha x plus beta y. So I can start from this number. Substitute this, I can open this bracket, a alpha u plus a beta v. Alpha is a scalar number, I can take is outside, plus beta times a into v. What is the au? Au is my t of u, fine, and av will be my t of v. So that's satisfied. Hence this is my linear transformation. Don't forget to like and comment on the video. Okay, 0 and minus x. This is a linear. This is a linear. So yes, this is a linear transformation. Does the 0 satisfied? Yes, 0 satisfied. Fine. Now choose, because it's a linear transformation, so you have to prove by the proper definition. So u I can choose as x1 y1, v I can choose as a x2 y2. So what is the t of u? Minus 0 and minus x1, 0 and minus x2. Start with the alpha u plus beta v. What is the value of this number? So this is a 0. This complete is my x. Again, I can write the first component as corresponding to the alpha terms and the second is corresponding to the beta terms. I can take alpha common from this, 0 comma minus x1. From here beta I can common, 0 comma minus x2. So clearly say 0 comma minus x1 is t of u and this is my t of v. Therefore, it is a linear transformation. What is a P2? Is a polynomial. Again you can see this is a linear, beta is a linear, this is linear, this is linear. Yes, this is a linear transformation. Remember, x is a polynomial. You can't say that x, because of the x it's a non-linear. The factor is only alpha, beta and gamma. So does the 0 satisfied? So if I take a will be my 0 0 0. So alpha is my 0. So it will be 0. Beta plus gamma, that is a diagonal of diagonal elements. Gamma delta is 0. So 0 will satisfy. I can choose a and b are the two elements of this kind. Now you have to find the alpha u plus beta v. Now since alpha and beta already written, so I instead of the alpha and beta I can choose any other number, say a and b. Fine. And instead of the a and b or u and v, I can take it as a and b. So if you multiply this by a, this by b and this number, then what is the value of t of this part? It will be alpha. Alpha is the first A11 element. This is the A11 element. Beta is my A12 element. Gamma is my A21 element. So I can add them. Now I can open this bracket, take the first bracket corresponding to the alpha terms, second bracket corresponding to the, instead of the alpha is a and b. I can take a as a common from this bracket. What is this part? This is my t of a and this is t of b. Hence it is a linear transformation. Similar, this is the same case. V is the set of all those n cross n matrix. P is a fixed vector. This is the most important thing. Fine. Otherwise you can see AP is look like a nonlinear because the degree is 2. Fine. But once P is my fixed matrix, that is a constant matrix, it can be 1, 2, 3, 4. Fine. So if you multiply this by A, it is a linear matrix. Now again, proof is very simple. I can start with the alpha A and this. Fine. What is the meaning of this? T of A will be AP minus PA. T of B will be BP minus PB. Now I can substitute this value at this point. A is my this number. I can open this bracket and take the pair of the alpha as one bracket and beta as a other bracket. I can take alpha as a common. You will get AP minus PA. AP minus PA is my T of A. This is my T of B. Hence it is my linear transformation. This question I will put an exercise for you. You can let me know whether this question is a linear transformation or not. You can prove that and send your answer in my comment box so that I can understand whether you learn this lecture in a simple manner or not. I hope you can like, comment and subscribe my YouTube channel. You can share this video with your friends. We will see the next lecture how you can write the matrix representation of the linear transformation. Till then, best of luck students. Happy learning.